In these examples, what we're going to do is we're going to plot some rectangular points, and then we're going to convert them to their polar equivalents. And in fact, we're going to get two versions of their polar equivalents just to get a little more familiar with this. So the first thing I want to do for these is actually draw some grids. All right, so, and obviously plotting points, you should be familiar with that by now. You've been through algebra and all this stuff. So the first one is 1, 0, right? My x coordinate is 1, my y coordinate is 0. Okay, simple enough. I've plotted that. In fact, I'm just going to go ahead and plot all these, right? And this one, it's -4, -4 1/3. -2 square root of 2, -2 square root of 2, right? So actually in the third quadrant in both of these, we're not in any quadrant here. So I've picked these, or I've got these points plotted, so part A is done on all these. Now, how do we convert these to polar coordinates? Well, I can go over here, and I can say, okay, well, r squared equals x squared plus y squared, and tangent of theta is equal to y over x. Now, another thing we could say is this is equivalent to saying r is the square root of x squared plus y squared, and that's generally how you're going to do it when you're trying to figure out what r is. So when I do that, I say r is square root of 1 squared plus 0 squared, which is 1, okay? And then I have to say tangent of theta is 0 over 1, which is 0. So tangent of theta is 0. So what does that tell me? Well, I know that tangent is equal to 0 when theta is 0. So that tells me that, and also it could be something like theta is equal to, tangent is also 0 when theta is equal to, or is equal to pi. So you have to be careful there, right? But in the case where theta is pi, tangent of theta is 0, but it's like 0 divided by -1 instead of, in this case, it's 0 divided by +1. So that's kind of a little bit of an intricacy there. There's something called if you're using a computer, you use it, there's like an arctangent function, and if there's something, so it's like an atan, and then there's another function called atan2, or arctan2. It depends on what your computer programming language is. And by feeding in 2 numbers instead of 1 number, it actually gets you back the right answer. It doesn't have the same domain problems that the normal arctangent does. So all that to say, that tells me that theta is 0. So I have r is 1, theta 0. So that's one of my, so I actually end up with the same type of coordinate that I have here. However, I can give 2 representations. So I'm actually going to give you 3. One of them is something like 1, 2 pi. Because I could start here, and then I could go all the way around the world, and I'd still be pointed in that direction. So that's fine. Another way to think about that is that instead of pointing toward the point, what happens if I point exactly in the opposite direction? So what if I point in the exact opposite direction? Well, instead of going 1 step forward, I would have to go 1 step backward. So all 3 of these are equivalent representations of that same point. It's kind of good to keep that stuff in your pocket, because a lot of what you're doing in math is being clever, and you want to be familiar enough so that you can pick the clever or most useful representation to do what you're trying to do. Now, moving along, we've already plotted this point. Let's use our relationships here. We say, okay, r is the square root -4 squared plus -4 square root of 3 squared, which is the square root of 16 plus 48, which is the square root of 64, which is 8. So r is equal to 8 here. Now, alternatively, or not alternatively, but also tangent of theta is y over x, so -4 square root of 3 over -4, which is a positive square root of 3. Now, you may not know your unit circles here. Now, if you don't, it's going to be problematic for you. But if you know your unit circle, what you find is that this is pi over 3. Normally for this, but this actually does. I'm sorry. This would normally mean theta is pi over 3. But you got to be careful. You have to be actually really, really careful because theta isn't pi over 3. Notice that if I'm looking at this here, pi over 3 is in the first quadrant. This is clearly not in the first quadrant. So how did we end up with not pi over 3? Well, the answer is because this is a negative over negative. This is sort of that a tan 2 thing. So if I said theta was tangent inverse of this, if you're using a computer and you fed it the negative values, it actually wouldn't cancel those negative values. It would say, oh, it's not pi over 3, which is this. It's 4 pi over 3. So we're at 4 pi over 3 because both of them, because even though the negatives cancel, we're in that quadrant. This goes back to that same thing about all students take calculus. Well, all of the trig functions are positive in this quadrant, and only the tangent is positive in that quadrant. But if tangent's positive, you don't necessarily know which of the two quadrants you're in. If tangent's negative, you still don't know which of the two quadrants you're in. So you have to look and be in sort of apply logic to, okay, what do these values tell me so I can figure out what quadrant I'm in, so it'll tell me which thing is my actual angle. It's tricky. You have to be careful. So now I know theta is 4 pi over 3, r is 8. Right, I have a distance of 8. I went 4 pi over 3. So one of my answers is 8 4 pi over 3. Now another answer, I could have just said, okay, well I'll take that pi over 3 answer. But I know that it's not actually pi over 3 because I know that's pointed in the wrong direction. So I just do negative 8. So that's another way to solve it. If you if you end up with something like that, you're like, oh, it's just negative 8. You know, whatever, right? And there's probably a rule about essentially what the x, like if like the x value is negative, you can always just write it like this and then not worry. But that's probably beyond what we're trying to do here. So finally, let's take a look here. Negative square root of 2, 2 square root of 2, negative 2 square root of 2. Now we're also in third quadrant, so we have the same exact pitfalls. So then we're going to say, all right, r is the square root of negative 2 root 2 squared plus negative 2 root 2 squared. Now in the interest of I trust you to be able to do this on your own. The answer is 4. Just, if you don't trust me, work it out. You know, that's what you want to do, or hopefully you can do this on your own. Now for theta, again, I have tangent of theta is negative 2 root 2, negative 2 root 2. So tangent of theta is 1, which would normally be pi over 4 if we were in the first quadrant. But we're not in the first quadrant. We're in the third quadrant. So it's not 1 pi over 4. It's not 2 pi over 4. It's not 3 pi over 4. It's not 4 pi over 4. It's 5 pi over 4. So in this particular case, your polar coordinates are 4, 5 pi over 4. But another way you could do that is just say, I'm just going to be in the first quadrant, but in the opposite direction. So I'm going to point pi over 4 and walk backwards 4 steps, and I'll get to the same place. And that's it. Hopefully that was a little bit informative to you. Again, this is always much better if you do it. Go practice, do some problems, and it should sink in fairly quickly.